right, we're here to talk about how Amazon MGM Studios protects its most important data. We've got a comprehensive talk. We'll go over a little bit about why we're here, how we decide to protect our data, dive into the Trend MicroStack, and then see what's in store for the future. My name is Rafael Barrero. I'm Senior Manager of Site Reliability Engineering at Amazon Prime Video and Studios.
I'm Mike Milner, VP of Cloud Technology at Trend Micro.
And I'm Jason Warman. I run the technical group at Pack Genesis. We're a partner that works with Trend and Amazon.
Thank you, guys. All right, before I go into the data, I think it's important to give some context for why we're here and how we decide to protect that data. I think not a lot of people realize that there is a supply chain. It's a media supply chain. And that starts with the productions, creative production process. Our team works very closely with these productions to support their complex workflows, and we build those cloud capabilities within our technology services team to make sure that they are able to work on those workflows, get the data into the cloud, and upstream into the next step of the media supply chain. That media supply chain gets all the way to distribution up through Prime Video. And we're at the beginning of that process. They need a reliable, secure platform to do that, and that's what we provide. Some of these workflows traditionally were on-site, physical, on-prem infrastructure. And we're continually trying to move that into the cloud by providing studio in the cloud capabilities, editorial in the cloud capabilities, part of that. So you can imagine throughout the production process, it's a creative process which requires a lot of iteration over content, and which will include a lot of files generated, right? So we have about 20 to 50 buckets created per month to support our productions, and each production will get its own bucket, so we can isolate it, allocate it, protect it in its own unique way. In those buckets, we see about 80 million objects created in S3 per month, on average. We receive these via packages, via direct S3 uploads, could be using the internet, could be using Direct Connect. Additionally, we use Aspera for some workloads, and even snowmobiles for remote regions of the world. Also, our assets are getting bigger and bigger every year. Started with 800 gigabyte files that easily crossed the 1 terabyte, then the 2 terabyte, and most recently, we just saw a 3.125 gigabyte file.
And I know a lot of you that are in media and entertainment may be used to working with these sizes of files and sizes of data sets, but it's really become universal across a lot of industries. In this case, we're talking about raw video or mezzanine style video that can be these, hundreds of gigs or terabytes in a single object. But it can also be frame files, individual frames that are very small, but there's hundreds of thousands or millions of them. And of course, we see that elsewhere too. If you think of, legal documents, that can also be a big archive or a bunch of small little TIFF files of individual emails. It's sort of the same style or variety of data that we start to have this challenge of not only how do we scale to ingest it, but also scale to secure it.
Yeah. And it is a scale problem. Looking at our global presence, our infrastructure engineering team deploys across 27 different regions, across the AWS set of regions, so that we can provide support for a lot of these local productions. Could be Lord of the Rings, could be Los Iniciados. Some of these are happening in Latin America, Asia, Africa, Australia, 6 continents. And so it does become a scale problem when we have so many productions providing so much data to us, and we've got to make sure that those assets are protected.
Yeah, and I think part of that is, I guess this comes back to those challenges of where the data is coming from, both physically and who it's coming from, right? So, Raf mentioned earlier, there could be a production that, it's in a facility where we have a dedicated direct connect. That makes it a little bit easier. Sometimes it's a remote production where we've got some temporary bandwidth. We have to come over the public internet. And that's when we often put in things like Aspera that can accelerate that even in those high latency, high packet loss situations. But the other half is who the data is coming from, right? If it's an internal team, okay, that's good, but of course we all work with a lot of freelancers, business partners, folks that are really outside of the organization. So again, when we think of scaling the ingest process and the security process, we have to take into account all of these mechanisms where we're going to be creating objects, but also who they're coming from to make sure that we secure it.
Yep. So our goal is to secure those assets at scale. And we have hundreds and hundreds of productions that we support. Many, many buckets, right? Each production is getting a bucket. We're creating 20 to 50 buckets per month. Even with the strikes and the slowdown and the dip, we're expected to only ramp up more and more and more. So we definitely need something scalable, also across 27 regions, maybe even more. That could continue to grow, and so we need something that we can deploy worldwide. We also wanted something native, something that worked within our current framework, something that could be extendable and support all of our teams, whether it be our technology operations teams, media supply chain teams, our production technology teams. We also wanted the concept of real integrity, not just checking a box, right? Sometimes, we look at our security teams and they're asking for logs, they're asking for proof, but we also want to make sure that our solution provided real value by securing those assets. And then also, we wouldn't be Amazon without providing data and visibility into what that looks like. So I'll go a little bit into the architecture, and then I'll pass it off to Mike to go deeper into this. But this is a reference architecture of what the Trend Micro stack looks like. You can tell it's event-based here. It's decoupled. It's also serverless. These are all big benefits to trying to deploy across that many regions of the world and not having to necessarily run compute, EC2. Also, they've done it in a modern way where you can see some of these components like the storage stack. The storage stack ties itself to the S3 bucket where production data lands. It monitors that bucket, does it using EventBridge. And so it's been updated and modernized to be able to support any number of events happening in S3, and then hands off a pre-signed URL to the scanner stack. Scanner stack is kind of what the magic here where we're able to leverage Trend's big database, whether it be zero-day and any other malware detection algorithms that they have, and the definitions list to be able to understand whether or not we have malware detected, known bad files. And these are handed off using pre-signed URLs, which are actually really intelligent to use because you don't have to worry about complex permission systems across accounts, across roles, and thinking about that. You can use these pre-signed URLs to provide that access between stacks. Also, this stack isn't limited to run in a particular account, which we'll talk about later. It can also be distributed and decentralized. Finally, we get to the PostScan Stack. This PostScan Stack is where you might put a quarantine bucket. There's two different models to think about it. One, leveraging a promote model, where things go into a temporary bucket before they get promoted into the final destination bucket. Or you can look at it as a post action, where if malware is detected, it can be pushed into a quarantine bucket for later review. And one of the things that you can do is not just shove stuff in there and get it dumped into this quarantine, but you can also integrate it with your application architecture, let people know that it didn't, that there's some sort of malware, and build it into the process and workflow if you want to. A little bit about deployment, since deployment is a really big topic for us, especially when we're trying to look at how we organize as a group and an organization at scale. Our team leverages AWS organizations, so we can leverage some of the facilities there to deploy these stacks. When you're operating at scale, it's difficult to do a singleton account creation, bucket creation, and so we do leverage AWS organizations to deploy cross-member accounts. We also use Service Catalog. Service Catalog is a great benefit to us. So you can see here, we've decided to leverage Service Catalog to build upon some of those initial components, whether it be creating VPCs on a regular basis or deploying S3 buckets. Maybe we're looking at editorial in the cloud capabilities, whether it be Avid and other helper functions you can see on the screen. We also want it to be native, so we do leverage things like code pipeline, code commit, and you can see the pipeline there deploys these stacks into these member accounts. The member accounts allow us, the organization allows us to deploy into these member accounts, and that's one of the ways that we are sort of democratizing the productization of our infrastructure. So one of the things that infrastructure engineering does is productize the infrastructure. This helps our organization at large work with the productions and, in a way, provides that self-service. That self-service allows us to scale better as an organization, and it also gives us the repeatability that we need and the ability to hand off some of these operations to our technology operations team, our production technology team, and others. So here what we have on the screen is an actual look of a product that we've developed. It comes from Trend Micro's CloudFormation templates, but we've looked at tailoring it for production specifically. So you might notice we have a show code. That's a good idea since we want to know what's in a bucket and how we want to name it. We need to know what region it goes in. As we know, we've got 27 regions. We might be going into another region. We also want to make sure that there's metadata and tags associated with that. And this allows us to essentially take CloudFormation and parameterize it, provide it in a user interface that most teams, technical teams, can run with and execute, and then generate the actual infrastructure, provision the infrastructure behind it. So this not only deploys for existing, but we can also attach it to new buckets that not just create the S3 component, but also those three stacks, the scanner stack, the storage stack, and the PostScan stack. In addition, it'll create some of the configuration specifically around S3 that we want. I'd be remiss not to mention one of our leadership principles at Amazon, invent and simplify. And that's something that we do on a regular basis within technology services, is really to think about ways that we can provide efficiencies to our teams and also look at making sure that we're supporting our customers by doing something that maybe took days, weeks, into minutes. And so one of the things that we've done recently with the Trend APIs is to do an auto registration with the Cloud One portal. The Cloud One portal, you can go in there and click through a button, add a stack, the scanner stack, the storage stack, into Cloud One, so you've got visibility into what's happening from a malware detection perspective. But that could be somewhat cumbersome if it's a separate process. Someone's executing some CloudFormation, then you got to go into this portal. But they've got API-friendly documentation, and so programmatically we're able to attach that to the end of our process just so that it automatically happens every time we deploy a scanner and storage stack. We've done that using Lambda. Now I'll pass it off to Mike for some in-depth.
Thank you, Raphael. When I think back to when we started building this product, it warms my heart to see how deeply you've integrated this and the scale at which you're operating. Trend Micro does so much more than just malware scanning, but we are experts at malware, and we've been doing it a long time. And we're also experts at cloud and cloud infrastructure and cloud security. So the idea behind this product, our file storage security, was really to bring those two sets of expertise together and bring this capability to our customers in a way that was really cloud native, felt natural in the cloud, so that our customers could do exactly what you've heard here as Amazon MGM Studios is doing. Before we started this, customers would come to us and they know we are experts in malware, and they'd ask us, how can we scan our files in the cloud? And a lot of the solutions they had in their mind, or what they'd maybe tried before talking to us, involved using pieces of infrastructure in the cloud, either with a Trend Micro component deployed on an EC2 instance, or maybe something like ClamAV deployed on an instance trying to scan these files. And they usually came to talk to us because there were a lot of problems with that. There's a lot of disadvantages to using infrastructure for scanning. The big one is files need to be moved around more. You need to get a file onto the EC2 instance and then scan the file. Moving these files around can be really slow. And then you've got these files potentially lingering in places, so you have to worry about cleaning up and making sure that sensitive files aren't mixed with other files. All of these concerns you have to think about. You're also running machines, and they need to be kept up to date. You don't want insecure systems scanning your files. So you need to make sure that they're patched. You need to keep them updated, upgrade them when the OS updates. You need to manage malware definition updates yourself. So there's a lot of just maintenance cost to even have the capability. And then there's actual infrastructure cost. These servers are sitting there and they're running. If you've got 27 regions around the world, that means you really kind of need 27 minimum instances. If you want to scale, that means you need to scale up and down these instances, more things to maintain, to develop, to manage yourself, all so that you can scan for malware. And as you've heard, gigantic files are slow to move around. And if those gigantic files are something you want to get through your system quickly so that they can be edited or shared or distributed, you don't want this malware scanning to slow down the whole thing. So this was kind of the state of the art at the time. And we knew it wasn't great. Our customers were telling us it wasn't great. So we wanted to do something a bit better. And of course, we love AWS, and they have a lot of new technologies at the time, so we wanted to leverage some of this and deploy a serverless solution, see if we could cut out some of the disadvantages of infrastructure. So as you saw on Raphael's slide, what we've got here is the basic building blocks of the solution. So you've got an S3 bucket. You might have one, you might have hundreds, you might be, 40 to 50 every month. The scale doesn't really matter. What we do is we attach some serverless handlers, Lambda functions, to listen for these files being created. And once they're created, we queue scanning jobs. And then we've got a Lambda function in another stack, that scanner stack, that actually performs the scan. We wanted to build a solution that was simple when you needed simple, but could be more advanced if you needed something more advanced. And thankfully, the AWS components we use give us the flexibility to make this all work well. And of course, the biggest component that's kind of core to all of this is S3 itself. And S3 has been around for a long time. It was one of the first services ever launched by AWS. I think the first GA service ever as well. So it's not just core to storing files, but it's core to how AWS operates and how our customers use AWS. They're not just storing files. These files are moving through the systems. S3 is deeply integrated into a lot of the workflows that our customers are using. So there's a few key functionalities in S3 that make all of this serverless scanning possible. And one of the fundamental pieces is event notifications, specifically this object created event. And this is the only quote unquote code I have in the slide. But this object created star means this event is triggered anytime an object is created. And that might be if you just go into the S3 APIs and upload a file directly. But it also happens for any of the other ways that AWS provides to transfer files into S3, or partners to transfer files into S3. So even if you've got one of those big snowballs and you're sending it in the mail with a bunch of video files or whatever files, they're going to be uploaded into S3 eventually, and it's going to trigger these events. So this is our hook so that we can make sure any new object that gets created in S3 gets scanned. And in this case, it just runs that Lambda function which queues up the scan. The next big thing that S3 provides seems quite simple, but the range queries. So if you've got a multi-terabyte file, you can ask for the whole file, or you can ask just for a small piece of the file, specific range of bytes. And this is one area where Trend Micro has a big advantage. Our malware scanning engine is part of our core technology. We have deep expertise in exactly how it works and exactly what it needs to see. So when you're thinking about AWS Lambda, one of the big restrictions when it comes to scanning big files is you actually don't have that much temporary space. Now, they have increased it over the years. I think it started at like maybe 128 megabytes, then 256, and I don't know what it is now, but it's a bit bigger. So you can't just naively kind of take a giant file, bring it into AWS Lambda, and scan it. So the range queries give us a way to get around that. Our engine that's scanning for malware knows which bytes it needs to inspect. So even if you've got a giant file, it doesn't look at it all at once. It looks at smaller pieces to understand that file, understand the file type, and know where to look in that file to check for malware. So even if you've got a gigantic file, these range queries allowed us to just pull the bytes that we need, inspect them in the Lambda function, and give back a result. So that made things much, much faster because we didn't need to transfer over a network these giant files, just the bytes we needed to inspect. So a small capability in S3, but one that unlocked a lot of capability. Signed URLs, Raphael mentioned this. This is a big, just utility advantage. If you have multiple accounts across many regions, managing the permissions to give the scanner access to the files can be quite a bit to manage. So the signed URLs just provide a very simple way to give access to the scanner so that it can access the files that it needs to scan. And those are nicely time limited, so you know you're not leaving access to this file in places that it shouldn't be, just long enough for the file to be scanned, the results to be returned. And speaking of the results, the S3 object tagging. Just the ability to add additional data, metadata, onto an S3 object provides a very convenient way when we actually perform a scan to tag that file with the scan results, when it was scanned, and metadata about the scan itself. So that you can see through that metadata, was this file scanned, when was it scanned, and what was the result. So all of this comes together to provide a pretty powerful capability. We like bringing new AWS capabilities into our products. One of the more recent ones was S3 Object Lambda, which is a bit of a mouthful of a name, but what it effectively does is it gives you an opportunity to insert a Lambda function when you request a file or object from S3. So I already talked in the previous slide about objects being created. You're scanning the file when it comes into your system, so you can stop malware at that point. But our understanding of malware evolves over time. So a file that came in maybe wasn't detected on day one. That malware wasn't understood, it wasn't known. But those malware definitions change over time. So that file, maybe with malware, is in one of your buckets and it's been scanned. And you want to make sure that before anyone accesses the file, it gets scanned again. So with S3 Object Lambda, it gives you that capability, and we can use the same scanner setup that we've got already for scanning files on creation. Now we can scan them when those files are accessed. So now you've kind of covered both sides of things. You know when it comes in, you're scanning it, and you know when it comes out, you're scanning it. So this is a great example of how we work directly with AWS on new capabilities. We were launch partners on this. This is a Jeff Barr tweet when we actually launched this with AWS. And I love how rapidly AWS brings new capabilities, even to these quite foundational components. S3, like I said, it's not new, but AWS is still iterating, still adding new capabilities to allow us to enhance the way our products can help protect our customers. So I said before, it was key to us that we wanted to build a product that was easy for customers who needed something simple, but still allowed for extension. So if you just have an S3 bucket and you're just using it as a big file store, that's great. You can deploy the solution with a single CloudFormation template. We'll deploy the storage connector, it will deploy the scanner and connect them all up, and you'll get results. But if you need something more advanced, if you want to separate or centralize the scanning capability in maybe a security-specific account, and you have storage accounts all over the place, some maybe you're attaching to an existing bucket, others maybe you want to incorporate, like Raphael described, so that every time you create a new bucket, it's automatically going to be scanned. Another big ask we have is in that results handling. What do you do when you detect malware? You can do the promotion model. So you might have an unknown bucket. This is the bucket that you put things in as they come into your infrastructure. That file gets scanned, and if it's good, it gets promoted up to the bucket where you actually operate on that file. That way, bad files are kind of stopped at the gate. You can quarantine bad files. This is a kind of a traditional anti-malware approach where you've got all the files in your system flowing through, and as they get scanned, if we detect anything that's bad, that file can get bumped out of the system into a quarantine bucket where you can inspect it further, understand if this is a real risk and what that risk is. But what's important to us is that we don't know everything our customers want to do. These are two key use cases, but we have a lot of customers who want to do completely their own thing. They want to customize that action. Maybe they just want to delete the file, or who knows what. And if they have S3 deeply integrated into their own applications, maybe that file is part of a form where a user is uploading a PDF for an insurance claim or whatever, you might want to give feedback directly back as part of that workflow for your customer. So maybe you want to notify them that, hey, that file you uploaded has been rejected because we detected malware. So you can deeply integrate the scanning into your own application as well. So it gives our customers that flexibility to use this capability however they want. I talked earlier about scanning files on creation and scanning files when you access with S3 Object Lambda. We also have customers who have a requirement to scan files periodically. So if a file did come in, we now know it's malware because we've updated our definitions. Now you want to know if that file exists, even if it's not accessed for a while. So periodically scanning existing files is also a capability that we can customize. And this is actually one of the services that we provide at Trend Micro is customizing, so that our customer wants a particular setup, they have a particular use case, our support engineers can actually help them set that up. The custom resources with scanning, this is what I mentioned earlier, where maybe you wanted to use a custom resource in CloudFormation or a service catalog where every time you create that bucket, you are sure that security, that malware scanning is automatically enabled. This is something that a lot of customers do to know that we are allowing them to be secure by default. If they need scanning, they're confident that every bucket that's created has scanning enabled. So the serverless technology provided by AWS and these hooks and integrations in S3 have allowed us to bring this together into a very powerful product, bringing that malware scanning expertise into the cloud era. So just like S3, it allows it to be flexible. You don't have to worry about scaling machines. It scales as quickly as S3 scales because the scanning is being performed by serverless functions. Any file, any size, we can scan it. It also makes sure that it's very fast. Instead of talking about scanning in minutes, it brings it down to scanning in seconds, regardless of the size or type of the file. That reduces your infrastructure costs, reduces your overall costs, and reduces the maintenance that you need to perform. You don't need to update those malware definitions. We manage that for you. You don't need to patch your EC2 instances. There are no EC2 instances. So a lot of advantages for our customers. If you're not scanning anything, you're not paying for anything. Depending on your workflow, that might be a key advantage as well. And finally, because it's all serverless, if you're just starting out, if you're just trying AWS, you're just trying this capability, it all fits within the AWS free tier. So you can try it in your environment without any cost at all. So I think it's a pretty compelling example of bringing the serverless technology together to solve a real problem for our customers. Pass it back.
All right. Thanks, Mike. So where are we today? Here's a look at the Trend Cloud One dashboard. This is what you'll look at when you want to see the different types of actions that are being performed within the environment across the data set that you have, whether there's malware being detected, and this is something that we provide our content security teams, right? We talked a little bit earlier about how we need proof, right? And we're trusting Trend Micro with those definition databases. And at the same time, our security team is looking for evidence, proof, ways that they can get visibility into what's actually happening behind the scenes with this product. For us, growth in the future is absolute. Here we've got a chart that shows a little bit about what we're projecting for next year. Based on current trends, even with the strikes, we're looking for a very busy 2024. Probably about 2.25x increase for the next few months here. So we're going to continue to get more and more data, right? More and more data, more and more productions. That's going to continue to add to the problem set. And as we look at that problem set, we want to think about our competitive advantage and how we leverage that. And think, do we want to build it? Do we want to deploy compute, given the growing problem that we're going to continue to have? I think we'd rather focus on other things at the moment. So some takeaways for you all. It really comes down to thinking about the architecture, how you want to think about deploying it. I mentioned the two or three stacks that you can deploy with this product versus deploying your own, managing your own, and then also thinking about whether you want to have it in one account, multiple accounts per region, deploy centralized in one scanner for this particular region, the other region. So there's a lot of considerations to make up when you look at that reference architecture. In addition to performance and costs, Mike mentioned this quite a bit, but there is a cost of ownership as well. When you're looking at running this many regions, this many files, this many objects being created all the time, the velocity of the files is going to continue to increase, and so you also need to have some way of scaling that out, and that's going to come with that cost consideration. So for us, it meant to look at a serverless application that allows us, again, to lower our cost for this particular type of solution, and then focus our efforts on engineering. Also, the security model, access for this particular Trend Cloud One dashboard, versus also how you look at permissions. Complex permissions can get unwieldy, right? And so looking at the way that Trend has innovated and provided the pre-signed URLs, also providing access to that scanner stack, the Cloud One dashboard, that can be done a variety of ways, and it can be provided to a security team. Access can be limited to one particular stack versus another, kind of goes back to architecture. And then overall, providing that process for the security team, content security team, application security team, global infrastructure security, to be able to understand exactly how we're securing those assets and how we're providing that value. And finally, the deployment model. A lot of different ways of skinning a cat, whether you want to use CloudFormation, Service Catalog products, the different developer tools, Terraform, infrastructure as code. When it comes to the scale problem, we have to think about infrastructure as code, and we want to make sure that we're trying to be efficient as possible and deploying this in a way that allows our teams internally to have that self-service model. So again, more productization and trying to build that value within our organization, not just from a security perspective, but also from an automation perspective. Thank you very much.